Hi students, today we are going to see a sum trigonometric identities, right? Sum number 7, right? Prove the following identities, right? See in this sum number 7, what we are going to see means, right? When we are having root, right? When we are having root, how we want to prove that, right? How we want to prove that. That alone we are going to see a new thing in this sum, right? So sum number 7, prove the following identities. Subdivision number 1, square root of 1 plus sin A divided by 1 minus sin A is equal to ck plus tan A. Ck plus tan A. So LHS is equal to, right? What is LHS? I'm just going to take the LHS and I'm going to bring the RHS, right? So LHS is equal to square root of, right, 1 plus sin A divided by 1 minus sin A, right? 1 plus sin A divided by 1 minus sin A. How we are going to prove that? How we are going to prove that? Very simple, right? So see that I told you that only one term, we are having only one term, and that is it is in the form of fraction, right? Then what we want to do that, I told you that we want to do the rationalize the denominator, that method, right? So same thing, what I'm going to do means I'm not at all going to remove the root. I'm just going to keep the root as it is, right? And just I'm taking the denominator, I'm going to do the method of rationalize the denominator method. I'm going to simplify and try to bring the RHS, right? If it is not so, we can't bring the RHS, right? See, we are having the two terms in RHS. Just take the RHS and simplify, right? Then we'll get LHS is equal to RHS, right? Understood? See, we are having LHS also, we can do the simplification, right? It is in the form of fraction. In denominator we are having two terms. If we are having two terms, we can use rationalize the denominator method, right? At the same time, RHS also we are having two terms, right? We can simplify, right? We can simplify in terms of ck and tan A. We can convert in terms of sin cos, and we will get in the form of fraction. After getting in the form of fraction, we can do the simplification, right? So we can use this method. We can use that method, right? First I'm going to taking the LHS and I'm trying to bring the RHS. If it is not so, then I'm going to take separately RHS and I'm going to simplify separately, right? Okay, see here what I'm going to do, rationalize the denominator. So see the denominator, how it will be 1 minus sin A. So we want to multiply and divide, right? Multiply by 1 plus sin A on both numerator and denominator, right? Denominator. So it is equal to, right? This is equal to square root of, the root should be for all the one, right? Square root of 1 plus sin A divided by 1 minus sin A into 1 plus sin A by 1 plus sin A. I'm just multiplying both numerator and denominator by 1 plus sin A. Rationalize the denominator, that method. See, 1 minus sin A is there. So I want to multiply by the complete opposite symbol, right? 1 minus sin A means 1 plus sin A by 1 plus sin A. Now just multiply square root of, the root should be, you have to write all the time, right? So 1 plus sin A into 1 plus sin A is something but 1 plus sin A the whole square divided by 1 minus sin A into 1 plus sin A. 1 minus sin A into 1 plus sin A. How it will be? 1 plus sin A is nothing but A plus B whole square format, right? A plus B whole square is nothing but, what is it? A square plus B square plus 2AB, right? Algebraic identities. In the denominator, how it will be? A minus B into A plus B. A minus B, right? A is nothing but 1 and B is nothing but sin A. A minus B into A plus B is equal to, what is it? A square minus B square. A square minus B square. So just apply the identity. It is nothing but square root of, right? Square root of 1 plus sin A the whole square. Just apply the identity. So what we will get it? 1 plus sin A is nothing but 1 plus sin square A plus 2 sin A, right? Or else shall we keep as it is? Shall we keep as it is? Then is it possible to simplify or not? We will check. If you are applying this square identity, right? If we are applying A plus B whole square identity, is it possible to simplify? Nothing is there. Better we can keep as it is, because see the denominator 1 minus sin A into 1 plus sin A will get 1 minus sin square A, right? 1 minus sin square A. Is it possible to simplify? So 1 plus sin A the whole square, right? I'm just keeping the numerator as it is. Denominator alone, I'm just applying the identity. So 1 minus sin A into 1 plus sin A is nothing but 1 minus sin square A, right? 1 minus sin square A. So any other possible to simplify? Cancelling. Nothing is there. Then how we want to simplify? You have to analyze how we are going to simplify. Suppose see that if it is 1 plus sin A is there, 1 plus sin A is there, then we can get cancelled. Once again, if we are getting cancelling means, right, once again if we are elaborating, right, if we are expanding 1 minus sin square A, once again we'll get the same LHS, right, we will go in the reverse order only, right. So we can't go with that method, we have to analyze some other method. Which method is possible to simplify? Which method is possible to simplify? See, first see that 1 minus sin square A, already we know that algebraic identities, we know that 1 minus sin square A, right, 1 minus sin square A is equal to cos square A, right, 1 minus sin square A is equal to cos square A. So instead of 1 minus sin square A, shall I substitute cos square A? Why I am substituting cos square A means, if both the numerator and denominators are square, right, square identity, then we can remove the root, right, we can remove the root by cancelling square and square roots, right, and then we can simplify. That's why, right, for removing the root, right, I'm just making that the numerator and denominator already it is in the form of square format, so we can easily cancel it. But in the denominator we are having two terms, so I'm just converting in terms to one term, then it is easy to cancelling, right. So I'm just instead of 1 minus sin square A, what I'm going to substitute cos square A. So it is equal to square root of 1 plus sin A the whole square, 1 plus sin A the whole square divided by 1 minus sin square A is equal to cos square A, cos square A, right, cos square A. Now I'm just going to separate the root, right, I'm just going to separate the roots. So square root of 1 plus cos A, sin A, 1 plus sin A the whole square divided by root cos square A, right. I have separated the roots for numerator and denominator. Now we can simplify. Square root will get cancelled, square root will get cancelled. So remaining what is there? 1 plus sin A divided by cos A, 1 plus sin A divided by cos A. Now see the numerator we are having two terms, right. So what we want to prove, that ck plus tan A we want to prove that. What is the RHS? ck plus tan A we want to prove that, right. So see that I'm just dividing, I'm just separating the terms by using the denominator, right. 1 by cos A is nothing but ck, sin A by cos A is nothing but tan A. So I'm just separating the denominators, right. So 1 plus sin A divided by cos A is nothing but 1 by cos A plus sin A divided by cos A, sin A divided by cos A. 1 by cos A is nothing but ca plus sin A by cos A is nothing but tan A is equal to RHS, right. Second solution, square root of sec square theta plus sec square A plus cosec square A is equal to tan A plus cot A, right. Sec square A plus cosec square A equal to tan A cot A. So I am going to take the LHS and I am going to bring the RHS. If it is not so, we are taking the RHS and we can simplify, we will get the LHS is equal to RHS, right. I am just taking the LHS, right. LHS is equal to square root of sec square A plus cosec square A, sec square A plus cosec square A. Well, we are seeing that see the LHS, see how we can simplify. So we can convert the ck in terms of 1 by cos and cosec A we can in terms of 1 by sin, right, 1 by sin, and we'll get in the form of fraction. By doing the cross multiplication we can simplification. Otherwise we know the identity already, we know that, right, right, we can convert the sec A and cosec A, it is nothing but identity, right. Sec square A is equal to 1 plus tan square A and cosec square A is equal to 1 plus cot square A, right. See already that RHS is nothing but already it is in the form of tan A cot A. We can go with that method also, we will get the same answer. Otherwise if we are taking that what is it in terms of sin cos, that is also will get the same answer, right. Now I am going to use this second method, right. See now I am going to use that identity method using the trigonometric identity, right. Sec square A is equal to, you know that what we know that sec square A is equal to 1 plus tan square A, right, 1 plus tan square A, and cosec square A is equal to 1 plus cot square A, right, 1 plus cot square A. So instead of sec square A, what I am going to substitute 1 plus tan square A, and instead of cosec square A, what I am going to substitute 1 plus 1 plus cot square A, right, instead of cosec square A, 1 plus cot square A, and just simplify, we will get the solution. So it is equal to square root of sec square A is nothing but 1 plus tan square A plus cosec square A is nothing but 1 plus cot square A, 1 plus cot square A. So see that it is nothing but 1 plus 1 is equal to 2, right, 1 plus 1 is equal to 2. So tan square A plus cot square A plus 1 plus 1 is equal to, right, 2, right? Then is it any other possible to get simplification? Any other possible to get simplification? You have to analyze. That is, see, after that how we want to simplify, you have to analyze which method we can apply, you have to analyze. Any other method? A very simple method. While we are seeing this step, right, you have to come to the conclusion. See, tan square a plus cot square a plus 2, tan square a plus cot square a plus 2, how it will be, that's very important. You have to analyze. See, it is nothing but a square plus b square plus 2ab, right? Sir, I told you that a square plus b square plus 2ab, but only here 2 alone is there. Where is a and b means? What is a and what is b? A is nothing but tan a, right? A square is equal to tan square a. Then a is nothing but tan a, right? A equal to tan a. And b is nothing but cot a, right? B is nothing but cot a. 2ab is nothing but 2 into tan a into cot a, right? 2 into tan a into cot a, right? 2. So see, already we know that cot a is nothing but the reciprocal of tan a, 1 by tan a, right? Or tan a is nothing but 1 by cot a, right? Tan a is equal to reciprocal of cot a, 1 by cot a. Or cot a is equal to, already we know that cot a is equal to 1 by tan a. Then tan a will get cancelled, right? A and b, right? B is nothing but 1 by a, right? A and 1 by a will get cancelled. Or tan a, right? Tan a and 1 by tan a will get cancelled. So what will get? We'll get 2 only. So it is nothing but a square plus b square plus 2ab format. So this is nothing but expansion of a plus b the whole square, and that, right? This is nothing but a plus b the whole square format. Here a is nothing but what is it? Tan a, and b is nothing but what is it? Cot a. So this is nothing but it is equal to square root of tan a plus cot a the whole square. Tan a plus cot a the whole square, right? Tan a plus cot a the whole square. So then directly we can cancel it. Square root will get cancelled. So remaining what is it? Tan a plus cot a. What we want to prove that? Tan a plus cot a only we want to prove that. Tan a plus cot a only we want to RHS. Right? See, still we are having some other method, right? Instead of, I told you that, see, I'm just using this identity. Suppose if you can't get this idea, we are having one more idea. What does that mean? See, I'm from this step onwards, I'm just simplifying, right? From this step, see, actually this is over, right? I'm just showing another way, right? How we can bring this RHS once again, some other method. 6 square a plus 6 square a is nothing but I'm just converting in terms of sin cos. So square root of what is 6 ck? 1 by cos a, right? Ck is nothing but 1 by cos a. So 1 by cos square a plus cos square a is nothing but 1 by sin square a, right? 1 by sin square a. Just do the simplification. Sin square a plus cos square a, doing cross multiplication, into cos square a divided by sin square a, right? Root, it is equal to sin square a plus cos square is nothing but 1, right? 1 divided by cos square a into sin square a, right? Square root of, right? Now we can directly see that we are having only one term, right? So it is equal to, we can cancel it, right? So 1 by cos a into 1 by cos a into sin a, right? Is it any other possible to simplification? Is it any other possible to simplify? See, I'm just doing roughly, already we have completed that one, right? I'm just showing that we are having another way to prove that LHS is equal to RHS, right? That's why. See, is there any other possible to simplify? We can't, right? While we are simplifying in terms of cos and sin, this is the maximum possibility, right? Hereafter we can simplify 1 by cos a is nothing but ck, 1 by sin a is nothing but cosec a. Right, likewise only we can convert, but what we want to prove that RHS is nothing but tan a plus cot a, right? So we can stop here itself, right? We are having only one term and this is the final step, so we can stop here itself. We can take the RHS separately. What is RHS? Tan a plus cot a, right? Tan a plus cot a. Tan a is equal to what is it? Sin a divided by cos a plus cos a divided by sin a, right? Cos a divided by sin a. Just do the cross multiplication, right? So sin a into sin a is nothing but sin square a plus cos a into cos a, cos square a divided by cos a into sin a, right? What is sin square a plus cos square a? It is equal to 1. So 1 divided by cos a into sin a. So already see that LHS, what we have proved that LHS is nothing but 1 by cos a into sin a. What is RHS? We have proved 1 by cos a into sin a. So LHS is equal to RHS, right? See, I'm just using this method. Still we are having so many, right? So we are having a plenty of way to prove this trigonometric identities, this concept fully, right? So you have to analyze which method we can apply, which is possible, right? Which while we are applying this one, should any other possible to do within a few steps. It's the few steps are not at all very important, right? Doing by 10 steps and we are getting a proof, that's not a big one. Within a 5 steps, but you have to use a steps correctly. That is very important, right? That is very important. Yeah, we have to prove correctly, right? While you are applying that any formulas, right? You have to it's suitable or not, right? If there is no square, right? Sin square theta is equal to only what is it? 1 plus cos square theta, right? Sin square theta is equal to what is it? 1 minus cos square theta, right? Sin square theta is equal to, sin theta is equal to 1 minus cos square theta. This is right? No, it is not at all possible. See, when we are having sin square theta, then only. Otherwise, we can write sin theta is equal to what is it? Square root of 1 minus cos square theta. That is possible. Sin square theta is equal to 1 minus cos square theta. Then sin theta is nothing but what is it? Square root of 1 minus cos square theta, right? While you are writing, substituting, right? That you have to substitute the exact formula, that the exact values. That is very important, right? What are your homework sums? Second subdivision, third subdivision, already we have completed 2 subdivisions. Third subdivision, square root of 1 plus cos theta divided by 1 minus cos theta is equal to cosec theta plus cot theta, right? So see that only one term, just take the LHS, just do the cross multiply, then we'll get the RHS, right? Then just do using identity, we can simplify. Subdivision number 4, square root of 1 minus cos theta divided by 1 plus cos theta plus square root of 1 plus cos theta divided by 1 minus cos theta, right? So you don't want to do the cross multiplication, right? See, rationalized denominator. See, already we are having 2 terms, right? And both are in terms of fraction. First you can do that. See, separate the root, right? Separate the root for numerator and denominator. Separate the root for numerator and denominator and just do the cross multiply, right? See, root 1 minus cos theta in root 1 minus cos theta will get what is it? 1 minus cos theta. See, I told you that already we know that what is it? Root 2 into root 2 is equal to what is it? 2. Same like that, root 1 minus cos theta into root 1 minus cos theta is nothing but 1 minus cos theta. And root 1 plus cos theta into root 1 plus cos theta, 1 plus cos theta, right? Likewise, while we are simplifying, we will get the RHS. Understood? While we are simplifying, be conscious, right? See, we are having 2 terms and see fully root, right? Fully root, right? While we are multiplying, we will get the correct values. Sum number 8. Prove that cos A minus sin A plus 1 divided by cos A plus sin A minus 1 is equal to cosec A plus cot A is equal to cosec A plus cot A by using the identity cosec square A is equal to 1 plus cot square A. Cosec square A is equal to 1 plus cot square A. By using this identity, we want to prove that cos A minus sin A plus 1 divided by cos A plus sin A minus 1 is equal to cosec A plus cot A. See, and this method is very important, right? Somewhat important. This all the sums are very important, but this method you have to keep while they are asking this method, right? You have to keep, then only it will be keep some hint to prove the RHS, right? While you have to keep some hint to prove the RHS. That's why I'm just giving that important, right? So I'm just taking the LHS and I'm going to bring the RHS, right? So LHS, what is LHS? LHS is equal to cos A minus sin A plus 1 divided by cos A plus sin A minus 1, right? So we have to, they itself said that, what is it? Using the identity cosec A square A is equal to 1 plus cot square A, right? By using this identity, they ask you to prove this, the above LHS is equal to RHS, right? The above proof, right? So how we can use this property? How we can use this identity? Cosec square A is equal to 1 plus cot square A. It is in the form of cos A, sin A and 1. How we can? And what we want to prove that? Cosec A plus cot A, right? RHS is nothing but cosec A plus cot A. See, how we are going to use this identity means very simple. Cosec square A, if we are having cosec square A, then we can apply 1 plus cot square A. If we are having cot square A, we can apply cosec square A minus 1, right? Cot square A is equal to minus 1. See, cos square A is equal to cosec square A minus 1, right? Then 1 is equal to cosec square A minus cot square A. We can use that identity. Here we are having 1, right? We are having 1. So we are having 1 means then instead of 1, what we can apply? Cosec square A minus cot square A we can apply, right? Cosec square A minus cot square A we can apply. So there is a possible for applying this identity. Here 1 is there. Instead of that 1, we can apply this identity. Okay. Before that, we want to keep one hint in your mind. While you are solving this model sum, right? You have to keep one small hint, right? A small hint. You have to keep it in your mind. Then only it will be very easy to simplify. See what we want to prove that. See, I'm just taking the LHS and I'm just going to prove the RHS. What is the RHS? Cosec A and cot A. Cosec A and cot A, right? See, just see the numerator and denominator. We have to convert this numerator and denominator in terms of cosec A and cot A. In terms of cosec A and cot A. How we are going to convert this numerator and denominator in terms of cosec A and cot A with 1. That's very needed, right? We have to convert this numerator and denominator in terms of cosec A and cot A with this 1 also, right? The 1 should be the same, right? So how we can convert this cosec in this LHS in terms of cosec A and cot A? Very simple. So see, while we are dividing this cos A by sin A or cos A, right? Cos A by cos A will get 1. Sin A by cos A. Sin A by cos A is nothing but what is it? Tan A. And 1 by cos A is nothing but sec A. I'm just taking a small example. If I am dividing this numerator by, right? If I am dividing this numerator by cos A, right? Already what is the numerator? Cos A minus sin A plus 1, right? Cos A. I'm just taking one example, right? Cos A minus sin A plus 1. I'm just dividing by cos A. Then cos A by cos A minus sin A by cos A plus 1 by cos A, right? Cos A by cos A is nothing but 1. Minus sin A by cos A is nothing but tan A, and 1 by cos A is nothing but sec A, right? So I told you that what we want to prove that. We want to prove that we have to convert this numerator and denominator in terms of cosec A and cot A. But what we are getting tan A and sec A. How we can convert this in terms of cosec and cot A? See, instead of dividing by cos A, you can divide by sin A, right? You can divide by both numerator and denominator in terms of sin A, right? This one you have to analyze. By you are dividing by sin or cos, we want to get this one, right? I'm just dividing by sin A. Cos A by sin A is nothing but what is it? Cos A by sin A is nothing but cot A, right? Cos A by sin A, cot A minus sin A will get cancelled 1 plus 1 by sin A is nothing but cosec A, right? So we have converted in terms of cot, cosec and 1. Cot, cosec and 1. So better we can divide this both numerator and denominator by sin A. Right, I'm just going to divide by both numerator. So divide both numerator and denominator, right? Divide by sin theta, right? Divide by sin A, right? Divide by sin A on both numerator and denominator. So it is equal to cos A minus sin A plus 1 divided by sin A whole divided by, once again what is it? Cos A plus sin A minus 1 divided by sin A, right? I'm just going to split up the sin A for all the 3 terms in numerator. At the same time, I'm just going to split up the sin A for all the 3 terms in the denominator also, right? So it is equal to cos A divided by sin A minus sin A divided by sin A plus 1 by sin A whole divided by cos A divided by sin A plus sin A divided by sin A plus 1 by sin A, right? So cos A by sin A is equal to, sorry, I have the small mistake here, minus 1 is there in the denominator. I have put a plus here, minus 1 by sin A, right? Okay, cos A by sin A is nothing but cot A minus sin A will get cancelled 1 plus 1 by sin A is nothing but cosec A divided by cos A by sin A, cot A plus sin A will get cancelled 1 minus 1 by sin A is nothing but cosec A, right? See, we are having the numerator also we are having 1 and denominator also we are having 1, right? Numerator also we are having, I'm just taking this 1 to the at the last term, right? So what is it? Cot A plus cosec A minus 1 divided by cot A minus cosec A plus 1, right? I'm just taking this plus 1 to the last and minus 1 to the last term, right? Okay, now see that, see the RHS, just compare the RHS. Now see that cosec A plus cot A it is in numerator or denominator. If it is in numerator, that instead of that 1 we have to write, instead of that 1 cosec square A minus cot square A, we have to substitute. If it is a 1 by cosec A plus cot A means, right, in the denominator 1, right, in the denominator 1, instead of this 1 we want to apply the identity cosec square A minus cot square A, right? So here what I'm going to see, instead of this 1, right, instead of this 1, what I'm going to substitute, 1 is equal to, what is it, cosec square A minus cot square A. I'm going to apply the identity cosec square A minus cot square A, right? Instead of this 1, what I'm going to apply, cosec square A minus cot square A, right? Suppose in the proof RHS, right, suppose the 1 by cosec A plus cot A means, right, so instead of this 1, right, denominator 1, we have to apply this identity, right? Okay, here they ask you to prove in the numerator alone. So instead of this numerator 1, I'm going to apply this identity. So what is it? Cot A plus cosec A minus, open the bracket, cosec square A minus cot square A. Cosec square A minus cot square A whole divided by cot A minus cosec A plus 1. Right? Cot A minus cosec A plus 1. Now see that, is it any other possible to simplify? Any other possible? You have to analyze. Denominator, nothing is possible. Numerator, yes. See the numerator, cosec square A minus cot square A, how it will be? A square minus B square, right? A square minus B square. What is the formula of A square minus B square? A plus B into A minus B. A plus B into A minus B. Shall I bracket these two terms? I'm just bracketing. So it is equal to cot A plus cosec A minus, so cosec square A minus cot square A, that is A square minus B square. So A plus B into A minus B, that is cosec A plus cot A into cosec A minus cot A. Cosec A into minus cot A, close the bracket, right, divided by cot A minus cosec A plus 1, right? Now why I am just applying this identity means, just compare the terms. Now how many terms we are having? This fully one term and this fully one term. We are having two terms, right? We are having two terms. See, cot A plus cosec A, cot A plus cosec A, like terms. So I take the like terms, common terms outside, and these two are the common terms. See, for this term this is common and this term this is common. So I take commonly outside. So while I am just taking this common term outside, what is the common term? So it is equal to cot A plus cosec A, right? Cot A plus cosec A, I'm just taking outside. So what is the remaining? Cot A plus cosec A, I'm just taking commonly outside. So what is the remaining? 1 minus, open the bracket, cosec A minus cot A, right? The first term I have taken cot A plus cosec A outside, so I have used 1 minus, right, in these two terms, right, in this bracket we are having two terms, right? This is common term I have taken outside, so remaining what is that? Cosec A minus cot A, right, whole divided by, see, why I am taking this much time means this is very important, right? That's why, divided by cot A minus cosec A plus 1, right? Cot A minus cosec A plus 1, right? While you are applying the minus inside, right, while I'm just applying the minus inside, then minus cosec A plus cot A, right? Minus cosec A plus cot A. Just apply the minus inside by removing the bracket, right? See, in this step I have to go with the another step, but we don't have space, so I'm just multiplying here itself. Minus into cosec A minus cosec A, minus into minus plus, right, plus cot A, right? 1 minus cosec A plus cot A. Just see, compare the denominator, 1 minus cosec A plus cot A, 1 minus cosec A plus cot A. Shall I cancel? Shall I cancel this whole term? So what is the remaining? It is equal to cot A plus cosec A. What we want to prove that? That is RHS. We got the RHS. Why I am just using this identity and why I am just taking the common terms means for cancelling the numerator and denominator. That's why I am just taking commonly outside, right? While I am just multiplying minus inside. You just got a minus cosec A, minus into minus minus cot A, it will become plus cot A. So 1 minus cosec A plus cot A, right? And this fully one term and this fully one term, both are same. I am just cancelling. Then we are getting, what is it? Cot A plus cosec A. We got the RHS. Understood? Homework sum number 9, same model, right? Already what we have solved in sum number 8, the same thing, right? Prove that sin theta minus cos theta plus 1 divided by sin theta plus cos theta minus 1, right? Plus 1, here minus 1. It is equal to sec theta plus tan theta. By using the identity, sec square theta is equal to 1 plus tan square theta, right? So we have to convert this LHS and RHS in terms of secant term and see that it is in the numerator. So instead of 1, what we want to apply? Sec square theta minus tan square theta identity. By using the taking the common term and simplifying, we'll get the RHS, right? Same model. Sum number 10. Prove that tan theta plus sec theta plus 1 divided by sec theta minus tan theta plus 1 is equal to 1 by sec theta minus tan theta. By using the identity, we want to prove that sec square theta is we want to prove that 1 by sec theta minus tan theta. By using this identity, we want to prove that sec square theta is equal to 1 plus tan square theta, right? See, in the sum number 9, they didn't give in terms of secant term. So what we want to do, we have to take the LHS and we have to convert in terms of secant term. But in the sum number 10, already they have given in terms of secant term. So we don't want to convert in terms of secant term. Directly we can apply the identity. Where we want to apply? For which one? Numerator 1 or denominator 1 we want to apply? For denominator 1, we want to apply this identity. Sec square theta minus tan square theta identity apply. We want to apply, right? Why? Because in the RHS, sec theta minus tan theta, it is in denominator, right? It is in denominator. So we have to apply in the denominator and just taking the common term and simplifying, we'll get the RHS, right? Thank you.